include authoring 5 books published in China and Germany, holding 2 patents in US and Korea, and publishing over 80 research papers in prestigious international journals and conferences. He is actively involved in the academic community, serving as an associate editor for the IEEE Access Journal, an editorial board member for the Journal of Information System Education, and an editorial review board member for the Social Science and Humanities Open Journal elsewhere. Dr. Rai's exceptional work has been recognized with several prestigious awards, including LG Best Paper Award and the Korean Computer Congress Best Paper Award in South Korea, as well as Best Paper Award at the International Conference on Behavioral and Educational Psychology conference, which held in USA. Notably, in 2013, he received Kilo Friendship Award, the greatest honored award bestowed by Shandong Province in China. And in 2019, he was granted the title of Honorary Citizen of Shandong Province for his significant contributions to the province development. He is also a recognized leader in his field, holding the distinction of senior member in both IEEE and ACM. Sir, we are delighted to have you with us today virtually. So on behalf of the organizing committee and entire audience, I extend a warm welcome to you, sir.
Thank you. Thank you for your wonderful introduction. So I want to say a few words before I begin my talk. First of all, good morning to all of you. And I'm very honored to be the part of this 4th International Conference on Recent Innovations in Computer Science. I would like to express my sincere gratitude and to respected principal of this institution, Professor Maya sir, and Professor Nagaraj Hebbar, and Dr. Sandeep Bhatt, and Assistant Professor Madhusudan for your kind invitation and support. And also the teacher, professor who introduced me right now. So I'm very proud to say that I'm a student of Professor Maya and a friend of Professor Hebbar for over 30 years now. And I also congratulate all the organizers, the participants, and moreover, the teachers and scholars who have presented in this conference. With this brief preface, I would like to start my talk. I think this talk is not really very difficult to understand. It is not very technical. As you know, the title is very simple. It says, From Text to Thought, the role of generative AI in building AGI systems. So this is the flow of my talk. I will start with some brief introduction to AI. And then I will introduce you what is the meaning of AGI. Actually, AGI is a very, very small area of artificial intelligence itself. And then generative AI, and of course, some introduction to large language models and text-to-thought transformation. Actually, this is, I have placed a question mark at the end of text-to-thought transformation, just to let you know that this is a kind of hypothetical idea, but it is happening right now. And some AI agent frameworks. And finally, some limitations, challenges, and risks. And then I conclude my talk with some concluding remarks. Now, this is a famous philosopher, Jiddu Krishnamurti, and maybe you have known him before. So he always said the thoughts become actions and the knowledge is limited. So today, with generative AI, it's very easy to generate thoughts or some process of thoughts. It doesn't mean that we are in the age of AGI, but we are, the potential of AGI is very strong. We are going in that direction. And also the knowledge is limited. It means that maybe some of you are using mobile phones. The phones what we are using some 5 years before, we are not using today. It doesn't mean that that phones are not useful. It only means that the knowledge is changed. That means every year we are continuously refining the knowledge. So that is why I have placed this title, what is that? The thinking, that means the text to thought. In fact, the text here means the prompt. I think that is the word we used. The prompt is actually a question we ask to the generative AI. In fact, in the database, we use the word query. Query is the question asked to the database. So let me just give you what happened in the last few years. Actually, everything what I'm going to talk today, it happened in the past just 3 years. So to be exact, it started in November 30, 2022. And that is the date where the OpenAI released ChatGPT. The original name for ChatGPT is Chat with GPT 3.5, but later they changed the name to ChatGPT. Now we know ChatGPT is a very, what you call, a kind of a buzzword everywhere. Now, what is the power of AI in the recent years? If you look at the first top news article, actually there is an AI developed by Google, DeepMind. It won the International Mathematical Olympiad silver medal. Now, just to talk about mathematics, if you go to some website called Play Math or Play Mathematics Institute, so there are some 7 unsolved problems in the world. That means if you're interested, you can go there, you can solve it. And if you solve these problems, they are open problems, you're going to get $1 million prize. Actually, there is only one problem solved some years before by a Russian mathematician called Gregory Perelman. Fortunately or unfortunately, he did not accept the prize, but the problems are still there. Maybe we are going to solve this kind of problems in the near future. There's a one aspect of it. Secondly, these problems, of course, there are 7 problems. There's one of the very widely discussed problems called Riemann hypothesis. And the secondly, you can see the second and third news articles. The last year Nobel Prize in both physics and chemistry is won by somebody who worked in Google. Maybe many people did not realize it. That means the Google is a very powerful company. For example, Jeffrey Hinton, he's right now he's not working with Google, but he's called as the father of deep learning, or you can call godfather of AI. He's called godfather of artificial intelligence, and he won the Nobel Prize with John Offield. And again, in the chemistry, there is 2 researchers also worked in Google DeepMind. So it shows that the artificial intelligence is not just entering one discipline. Actually, it is not just multidisciplinary. It is multidisciplinary, not interdisciplinary. So that means if you're in social sciences, if you're in law, if you're in humanities, English language, we all going to use AI in one or the other day. The last one shows the bar exam. That's actually lawyer exam. There is an exam called LSAT. That is a law school admission test in the US and Canada. Now, if you ask me which course is very difficult in the UK or US, it is a law. Even in the UK, it's very difficult to get a first class in law degree. So the GPT-4 beats 90% of humans in the world's toughest exam. So these are the growth of artificial intelligence in the recent days. So what I'm going to tell you is actually we call English language as a lingua franca in linguistics. That means if you want to travel any country, the English is the most important, irrespective of the language spoken in that country. And similarly, C language is also called as a lingua franca because C language, if you know the C language, it's very easy to learn the syntax or semantics of other languages, just like Java or Python. So I would like to say that the AI is like that. AI is going to become a lingua franca for all disciplines. That means if you're a lawyer, if you're a teacher, if you have some expertise in artificial intelligence, that means you're going to be very competitive in the market. So now there are a lot of generative AI tools. As you can see in this slide, I have placed some of the tools. I have shown some of the tools, just like Gemini, ChatGPT, and even DeepSeek is from China. So there is so many powerful generative AI tools today. Now, why they become so popular? The reason is not because they are going to change everything.
Hello, sir. You're not audible to us. Sir, are you in call? Hello, sir. You're not audible to us. Sir, are you in call? Sir, you're not audible.
Hello, Lakshmisha. Please unmute. Unmute. Text. Unmute. Text.
Yes. Is it okay?
Yeah, okay. Can continue.
Okay. Sorry. Could you tell me where I stopped? From which slide this is finished? This is over?
Yeah, correct. From here. From here.
Okay. Okay. Sorry. Thank you. So I think it is also good to have some break for you. So let me just continue from here. As I said, there is now my voice is clear, right? So everything is fine now.
Yes, fine, sir. You can
Okay,
proceed.
thank you. Okay, if there is something, let me know because there is some issues that's quite possible. So this is what I said. What is actually the artificial intelligence is about? So it is basically a branch of computer science. As you know, there is a picture here. This is a photo of John McCarthy. Actually, he coined the term artificial intelligence in 1956. And that conference is called Dartmouth Conference. And actually, this teacher's student is Professor Raj Reddy, who won the first Turing Prize, the first Asian to win the Turing Prize. The Turing is named after Alan M. Turing. So basically, artificial intelligence is the branch of computer science, but we should remember that the word opposite to artificial intelligence is the natural intelligence. So we born with natural intelligence. Similarly, there is a different kinds of intelligence, not just what you say. For example, there is in this slide there are 10 or I don't know, there is a 10 or 8 intelligences. They're called multiple intelligences. This is a Howard Gardner's research. So that means that ChatGPT or this generative AI is not able to reach or every kind of intelligence. Let us say musical intelligence or bodily kinesthetic intelligence and so on. So just to start to remind you, this is Alan M. Turing, actually Alan Matheson Turing. There is a biggest prize in computing called ACM Turing Prize, named after him. And he wrote a paper in 1950, exactly 75 years before, in the journal Mind. Actually, this journal is still there. It is published by Oxford University. So if you remember, if you read the title, it is called Computing Machinery and Intelligence. And the first line says, I propose to consider the question, can machines think? I think you can imagine that this is always done much earlier. But in fact, the original name for artificial intelligence is the machine intelligence. But later, the John McCarthy changed to artificial intelligence in 1956. And today, this is in 2017, there was a breakthrough paper. It is called Attention is All You Need. Now, if you're tired of listening to me or if you're bored, I want to tell you, attention is all you need. Now, this is a very strange title for a research paper by the Google Mind and others. Actually, you can see the first author, Ashish Vaswani. Now, right now he's the CEO of another company, his own company. I forget the name. But however, this is called a landmark paper written in 2017 by the Google. Unfortunately, the Google did not realize the importance of this paper. In the right side of you can see the transformer architecture. This transform architecture is the same GPT. GPT means generative pre-trained transformer, which is basically a neural network architecture. So what is interesting is the Google developed this idea, but they did not realize the importance of this paper. And it is a small company like OpenAI. And Sam Altman, his company, realized the importance and they developed this ChatGPT models. So why? Because there are so many papers people are publishing, but we don't read it properly. So now the Google is very worried because later on they found the importance of this idea. Now, this paper can be considered as one of the landmark paper in the history of AI. Now, if you want to understand what is the transform architecture, of course, this is where to begin. Now, I don't want to talk about the branches of artificial intelligence because artificial intelligence is everywhere. While I'm working with my Korean professor, so I did worked on expert systems. And expert systems is also called as, to some extent, the expert system is rule-based systems or knowledge-based systems. Actually, there is one journal called Knowledge-Based Systems, a very popular journal in this field. So it doesn't mean that generative AI is the only one field. There is so many other fields are coming together at this moment. And also, as I mentioned, the AI applications are everywhere. I think I will skip this. Now, this slide is quite important compared to the AI models. Now, actually, the word large language model, it says large because they have billions of parameters, which I will explain in a moment. And they are called large language models because they are basically come from NLP, the natural language processing, because we use a lot of text. And of course, there is a lot of models like DeepSeek and Gemini, Mistral, and even Cloud and so on. And you can see the cost for tokens. For example, if you use these models, they will charge some money because every token is the one word what we use. For example, if I say, this is good, it has 3 tokens. And if you add the full stop, it has a four tokens. So each token is charged because this use a lot of cost in terms of power. In fact, the power is very power in the means electricity. It costs a lot of energy. There was a story that recently there was a fire in California, and people blame the ChatGPT because they say that the machines are getting very hot, and that is why this heat generate power, because these machines get very hot. And I heard that they are pouring some let us say some 1 liter of water to cool down these kind of machines. That means every prompt you type in Google, and of course it also happens in Google, especially in generative AI, it contribute to some kind of what is called carbon emissions. So I want to start some of the use cases. And this is one use case. Now, let me just tell you, the DeepSeek is released just a few months before in China here. And if you see, this is some kind of Ogatugulu. I think you know what's Ogatugulu. So I asked the DeepSeek, write some Ogatugulu in Kannada. Now you can see, I'm sorry for those who are not fluent in Kannada. So you can see there is a very perfect Ogatugulu here. So absolutely, there is no mistakes. There is another slide here. But you may, and even I can translate this Ogatugulu to Chinese. Now, I can read some Chinese, not very fluent, but I can find, let us say, the top watermelon is called Shigua. So it's very perfect translation. That means you can generate and translate and, of course, refine much better. But I don't say it is very strange because these things you can find in Google. This is not a generative AI. This is a kind of extraction. It is extract what is already there. But generative AI is not like that. It is not like a Google. So let us say this is a Basavanna's Vachanas. Now here there is a Basavanna as a Vachanas in both in English and Kannada. Now, as you know, he lived somewhere in 12th century in Karnataka. So he was also the prime minister. So now I don't want to generate the vachanas of Basavannas, which is already there in the internet. Instead, what would be the situation if he is here with us today, and how the vachanas would change? The very important about Basavanna is he was a revolutionary figure. In fact, he's also considered the situation of the society, the people, and the culture and everything in those days. And most of his work is based on the society itself. So actually, just to mention this Basavanna, there was a statue of Basavanna in the opposite of London Parliament. If you have a chance, you should see it because of his contribution to the society. Now, my prompt here is a little bit different. Now, what I'm going to do, instead of asking Vachanas, I want the Basavanna, if he is today, how his Vachanas would look like. Now, my prompt is like this. How would the Vachanas appear if Basavanna were alive today and wrote about contemporary global developments such as transportation, communication, information technology, industrialization, and AI advancements? Please provide an example. Now, I'm asking only one Vachana in Kannada that reflects these themes written in Basavanna style. Then actually this DeepSeek asked me to refine the question. I'm not going to read it, but you understand what I'm trying to say. So, excuse me, 1 minute. Okay. So then it will generate this kind of Vachana. For example, it can see, you can see the Minchina, Gatiyali, and so on, and Manasina Nelayali. So it means that we always use mobile phones, and every 5 minutes, we don't want to escape from it. Actually, this is very meaningful Vachanas generated by the DeepSeek. So that means that we can move forward some 800 years, or maybe we can move backward too. Actually, this is used recently in some of the legal cases where if somebody is already dead and we want to hear from them, and this is one of the work, what we can do with generative AI. Now, there is another picture here. This picture I generate using a free pick AI tool. I asked the generative AI, okay, you generate an image of a building which looks like a rose flower. Now you can see how the buildings really looks like this. So what is I'm trying to say? So there are two claims. One is the claim one. It says the meaningful progress is being made toward superhuman capabilities. There's a claim one. And the claim two, it is plausible that this progress is continuous to superhuman levels. Now, if you look at where we are today, you can see some intersection point between the red line and the blue line. Actually, we are there. But the progress is very clear that we are actually going in that direction. So there are three categories of AI. What is called artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Now, basically, all the intelligence what we have today, it is narrow intelligence. It is not really called, it is also called as a weak intelligence. It could be anything. It could be, medical diagnosis or spam filtering or all kind of the work what we do. It is called narrow intelligence. Now, how it can be classified? Now, this is actually one picture which I refined myself. Actually, you can find the similar picture, but I clubbed everything recently and create this picture. The size of the box, if it is bigger, it means that there is more work is actually already done. In fact, the first top box should be much smaller, but just for drawing, looks a little bigger. But however, you can start from the lower level, the down box, which is artificial narrow intelligence. Now I have, because the people use different terms, there is a confusing on what is the weak AI, what is narrow AI. Actually, it is the same thing. Actually, artificial narrow intelligence is a weak AI, and it is basically single task based algorithms. And most of the AIs, what we use, deep learning or all applied, this all come under ANI, artificial narrow intelligence. If you go to the next level, that is what we are today. Actually, we are not really reached AGI, but our progress is towards AGI. AGI is also called as a general AI, but not generative AI, general AI, strong AI, and full AI. It is actually means we have reached the level of human intelligence. So that is the meaning. So it is also called AI complete, and then we have AI artificial super intelligence, where we exceed the human intelligence. And of course, this is based on a book called Super Intelligence. Now, what I'm trying to say that you may ask me, there is two questions here. One is how to classify the weak AI to the strong AI, because AGI is a strong AI. And of course, let me just tell you the first initially, what is the meaning of weak and strong AI. Now, the test for artificial general intelligence to classify weak or strong is called a Turing test. Now, I'm not sure this Turing test is really applicable today because it is proposed by Turing. Maybe if you're familiar, there is a movie called Imitation Game. In fact, that test is called Imitation Game. It is kind of a game. I hope you can see in the screen there is A, B, and C. There are three entities. Now, let us say the C is me and sitting behind the wall. That means I cannot see who is A and who is B because A and B are hidden from C. So we don't know, but I can talk to them. So what I'm going to do, I'm going to ask questions to A and B. Then I find both A and B could able to answer my questions very perfectly. So, but that means that I could not find the difference between A and B. So what does that mean? That means if you can't tell which of the entity is a human and which is a computer program, then you're fooled, and we should therefore consider computer to be intelligent. Now, this is a test for intelligence. So that is the intelligence. Now, it is not the test for weak or strong AI. This is the test to make sure the system is intelligent. Now, there is a lot of chatbots if you go to any universities, if you go to any customer service, there's a lot of chatbots. They act like intelligent. But only the problem with the Turing test, actually, there is so many other tests after Turing, but this is one of the tests to prove that the system is intelligent. But only problem is it is developed in 1950s. So now, and it is only text based. So that time they use a text based test for intelligence. Now, there is another important development called Chinese room argument. Now, this is nothing to do with the Chinese language. And this is proposed by a philosopher. He's not a computer scientist. His name is John Searle. And this is a test to find which AI is a strong or weak. Or just now I mentioned before, the AGI is called strong intelligence, and all the intelligence, all the AI, what we have today, they are weak. So the idea is very simple. This is a question for thinking. For example, as per, if you have, there is a photo, what you see here is called Searle. He's a professor in UCB. So retired professor. Now you can see the idea is very simple. We can translate from Chinese to English or Kannada to Hindi and so on. It's very easy today. But does it mean that the translator, the program, can really knows what is the input and what is the output? The answer is no. So this is a test for thinking. It means the no type of program could by itself can do something. That means they cannot think. They can do something. They cannot really think about what they are doing. That means the AGI programs can do many things, but they really don't know what they are doing, or they don't know what they don't know. So that is very simple like that. So they really don't know what they don't know. So that is why we classify the weak and strong intelligence. But this is something a very philosophical question too. Now I can go to the artificial general intelligence. Actually, there is so many definitions of AGI. Recently, the vice president of OpenAI gave a talk in IIT Madras. So he says, somebody asked, what is the definition of AGI? Then he says, the AGI is some tasks where we can save money. It is economical. It is a cost effective. So these kind of tasks are belongs to AGI, but I like this definition from Google DeepMind. It says an AI system or collection of systems that outperforms 99% of the skilled adults and most cognitive tasks. So you can imagine that means that doesn't mean that the AI is going to replace everything quickly, but definitely we can replace a lot of tasks, and then we can say that, okay, we reached the level of AGI. Now, what are the characteristics of AGI systems? Now, of course, the the AGI is very good in general learning ability. They are good in learning everything, not just mathematics or programming or other things. They are flexibility across diverse tasks. They have a human-like reasoning and the self-improvement. So that's very interesting because they can improve by themselves using recursive learning. And there are some use cases which I mentioned here. So the core pillars of AGI are generalization, reasoning, autonomy, and embodiment. Now, the first one, the transfer learning. Now, this is a very debatable topic because there is something called distillation or knowledge distillation. For example, you have one network which already learned something, then we use that information or that learned information to the another task, and that is what is a transfer learning. Then of course the autonomy, the self-improvement and embodiment. Now what would happen if we put a computer inside a robot and which has GPT power? That means it's very easy to make the machines to talk. This is quite impossible before, that it is not easy. We can have many machines to do many things, but it's very difficult to talk to them just like you and me. So that is why the embodiment is very powerful too. Now this slide is also from Google. So what they have done, they have classified AGI into different levels. Now, this is not something very great work, but I can just tell you there is a level 0, level 1, level 2, level 3, level 4, and level 5. And they can also tell you where we are today. For example, if you look at level 2, it says at least a 50th percentile of a skilled adults. So that means that the percentile score, only 50% it is above the 50% of the people of skilled adults. So we have not yet reached that level, but the progress is very strong. So you can see this slide can tell you the limitations. It can also tell you some of the emerging AGI, just like ChatGPT, Bard, LLMA, and so on. So there is a few words about artificial superintelligence. There is a book written by this Nick Bostrom called Superintelligence. So the superintelligence is the point where we reach the AI reach the capability above human beings. Now, then we may able to answer some questions just like a consciousness or a thought or maybe the mind. This may be some of the questions we may come across. But however, one of the limitations of artificial superintelligence or dangers is that if some AI becomes more powerful than us, then how to test it? Who is going to test the tester? It is something like that. So basically, there is a word called singularity. Now, it's very difficult to define what is a singularity. There is no perfect definition, but singularity is a moment where AI reach a level where it becomes uncontrollable and irreversible, and it is able to test by itself and also able to improve by itself. Now you can understand what I'm trying to say. So I will talk about directly the generative AI today. Now, this is a slide from some two teachers who wrote a book about education. I find this slide is quite good because it shows that generative AI is a very small part of LLMs, a small part of AI itself. You can see we have artificial intelligence, machine learning, artificial neural networks, deep learning, and then we have the LLMs, large language models, and text to image, even text to videos, and so on. So what is interesting is that what is actually the machine learning and artificial intelligence? There is one professor, he says the machine learning is what we do and artificial intelligence is what we are going to achieve. So you can see the difference here. So this, I think you have seen this kind of slide. It's very easy to understand. Usually this kind of neural networks, they are called deep neural networks because they are more hidden layers. There's the input layer, there's the output layer. As you can see in this picture, there is an image of a person, and then the edges are identified in the layer 1, then the combination of edges from the layer 2, and then layer 3, and finally the person's name is identified. But actually, what is this, how it is actually going to do? Now, this is a slide from Watson lecture. So you can see that there is some kind of knobs. Actually, these knobs are very similar to what we use in the tap water. Actually, one of the teachers said generative AI generates information just like a water tap, as if the water is flowing to the sink. Now, these taps are what we call as parameters. Now, that is where exactly the ChatGPT has 1 billion parameters, which I will explain in a moment. But remember, the parameters are not actually the nodes, so they are quite different. Now, as you can see, there is a picture of a cloud Shannon in the left side, and I feed this picture, input this picture to this learning neural network. The neural network can be tuned, or you can use the knobs such a way that it can identify this Cloud Shannon. As you know, the Cloud Shannon is called father of information theory. The Turing is called father of theoretical computer science. And so the Cloud Shannon, just to mention Cloud Shannon, he was also one of the participants in the 1956 conference when the John McCarthy coined the term AI. So just to tell you what is actually the parameters means. Now, we know this picture is a picture about neurons. Our brain has the billions of neurons, and these neurons are also connected to other neurons. Actually, if you remember something, it actually means there is more connections in the brain. But however, the more number of neurons do not mean this person is a clever. And also, the bigger the brain size does not mean that the person is very clever. So, for example, the elephants have thrice the size of neurons, around 250 billion neurons, and we have roughly 86 billion neurons. Now, the 1 billion has 9 zeros. That is why if somebody is very clever, we call him as an elephant brain, because the elephants has more number of neurons in their brain than humans. Just to compare the human brain to ChatGPT. Now, ChatGPT has 1.76 trillion parameters. Actually, 1 trillion include 12 zeros after 1. The human brain has 86 billion neurons. Now, you can see how big the ChatGPT is. Now, we call the trillion parameters. We don't call them nodes. They are not nodes. They are parameters. And the human brain we call nodes. Now, just to give an example here, how many parameters in this network? Now, this is a question maybe if students may get in the interview for some jobs like prompt engineering. Now, this is a very simple toy network. If you see this network, there is only 4 set of nodes, and there is so many connections. Now, these connections are similar to the weights. Now, what I can do, for example, if you start from the first to the second, there is a 3 input nodes, and there is a 4 nodes in the second level, because 1, 2, 3, 4. Let us say green to red, there are 4. So there are 12 connections. That means 3 into 4, 12. And the same 4 into 3 from second to third, third to fourth to 3 into 3. So that is the basic number of connections. As you can see, then I add some numbers, which is in the blue color, which actually indicates that I add something, what is called some kind of bias. Actually, when we add bias, I add 4. I add 4 in the first level, because from the first level to the second level, there are 4 nodes, and 4 and again 3 and 3. Then we have 43 parameters. So just this simple network has a 43 parameters, but ChatGPT has 1.76 billion parameters. So we can imagine the complexity of this network. So can we use ChatGPT on our computer? I don't know. As I said, this is a very introduction. Maybe some of you already done it. Actually, we can download this what is called the DeepSeek or LLMA and to the computer, because they're open source. And for example, I have myself downloaded the DeepSeek, which has a 7 billion parameters. And we can download it and we can train it. Of course, I'm not good in training how it is done, but however, I said we can download it. And this, what I have downloaded, they have 7 billion parameters. Now, I just caution you that if your computer is very, very slow, please be careful, because you have to shut down the computer many times, because it takes a lot of computing power. So you have to be a little careful about. That's why I downloaded 7 billion, and you can test it. Now, when you test this, LLMs, you really don't need to connect to the internet, because it is localized. And that is very benefit. That is how we create AGI frameworks, because we can customize to our demand. So in this case, I have asked them question about the 5 numbers, 52841, and give me the results. Of course, it give me the time complexity and average case and so on. So that means that you can do this by yourself and download it to your PC. Now, there is what is actually generative AI is all about. As I said, generative AI is, as you can see in the picture, there is a basically discriminative AI. All the AI, what we are doing today is discriminative. It is used for classification, just like we have a picture of Shannon here, and I feed this picture to the network, then it says the Cloud Shannon. But the generative AI is quite opposite. It is opposite. It shows it has a prompt, create a face, and then the neural network generate a face, which is actually did not exist before. So they have a lot of capabilities of generative AI. They can generate the text, they can generate images, they can generate videos, and for example, I like the code generation. They can generate a lot of programs in any languages. Actually, even I have written somewhere where you can generate code in C language and translate the code to the Python, or even other languages too. So you can use it for a code translation, and even to learn computer science. So that is the power of generative AI. So I think I can skip this. This is some kind of text generation, and recently we have multimodal capability to do. So there are many new terms are emerging every day. So we don't have to be worried about it. For example, recently the people are talking about ethical AI, responsible AI. Even I want to tell you, in some countries, in European countries, they don't want to use AI because they think it is a black box. Black box in the sense they really don't know how it works. And if they don't know how it works, they can't use it. So that is called explainable AI. These AIs cannot explainable. This is the same like a mobile phone. We use mobile phone, but we don't know what is inside, but we still use it. But in some countries, they have put a limitation on this kind of, they are debating how to use AI with the trust. That is called trusted AI too. Now, this slide shows, for example, a computer. If you see what is actually a computer, the computers were, the history of computer goes back to 1870s from the Charles Babbage computer called a difference engine. He was a mathematician. Because to solve the mathematical problems, we had developed computers. That is where it came from. But later on, we found that we don't need a computer. We can use the network or a Google. Because right now, if I want to multiply two numbers, I'm not going to use writing a program. I just directly use Google, and Google can help me. But now the model is the computer. Excuse me. So model is the computer in the sense the large language model can do exactly what the network and computer both can do. So it is just like what is called a supercomputer in your hand. So this is some of the history of large language models. It started in 1967. Actually, ELIZA is one of the first large language model, which is basically what we call as a machine conversational agent. And then we have LLMs today. But these large language models can able to predict the next word in a sentence based on the weight. As you can see here, the cat is chasing the mouse because there is a 70% weight. But also in the recent years, there is a small language models. Maybe you can search in the internet where people are also studying how to build the small language models itself. So there is a very important term in the recent days is the prompt engineering. If you look at in the internet, there's a lot of jobs for prompt engineering. So prompt engineering is all about asking the questions. Now here, I put a proverb from Stephen Wadakan. I don't know, you remember him. He lived in Mangalore and Nitte. So he says the genius is asking the right question and intelligence is finding the right answer. So if you know how to ask the right questions to these tools, that is actually meaning that you are going to be a good prompt engineer. But what a prompt engineer should need to know, actually he need to know everything. There is somewhere I read, it says that to raise a child, you need the whole village. And similarly, to use AGI, you need everything. So in the similar way, there is a prompt engineering is all about. So the prompt engineering is very simple. It is actually you are asking the most cost effective questions to the AI tools, because as I said, they are cost intensive, they need a lot of power. So if you keep on asking many, let us say, weak questions, it actually means we are spending a lot of power. In fact, at least the open AI is spending a lot of power because we are asking questions and using a lot of computing resources. But the most important here is asking the most cost effective and accurate, and also the outputs must be safe. It should not harm other programs and so on. So what is actually the text to thought transformation? Now, this I said is a kind of a hypothetical scenario. Maybe we can use the generative AI to generate structured knowledge. For example, you can ask what is the best way to learn mathematics, and many AI tools, they can generate a lot of answers. Then they try to refine the answer. They can refine the answer by themselves. And sometimes they say, sorry, okay, I want to give a new answer. So this is always possible. But however, the AI lacks consciousness, and that we all know because there is nothing like a consciousness in AI. That's not going to happen so easily. If you ask any AI, they say they are just programs. And there is one I forget this teacher's name, but she said these actually she is a very famous computer science professor in Washington. So she called this as a stochastic parrots. Actually, parrots in Kannada we call gilli. So that means that you can say something to these parrots and they repeat the same thing. They are not really thinking what they are doing. So this is a word which is very controversial in the recent days. The stochastic parrots means merely replicating what is encountered before. So these are some of the limitations itself. So if you're really interested in this kind of text to thought transformation, then one of the important is actually it's very easy to have tokenization programs, even embedding, but the contextualization. And that is where there is a word called the reactive AI and proactive AI. Now, in fact, the generative AI is called proactive AI because they are not just based on the past history, but they are also based on a lot of information which is available. For example, the bank is the one is the bank of river, another is the bank, just like a state bank, and so on. So there is an illusion of thought, because maybe we can say that these tools are very powerful because they create some illusion that as if it is true. It is because of only two reasons. One is the pattern recognition, and another is associative reasoning. For example, if you're talking about rain, then these tools could able to help you, to find an umbrella. They can link these kind of words very effectively. So there are some emergent behaviors. Actually, this is not something new. If you think about the prompting, there's a lot of prompting method, like a single shot prompting, few shot prompting, and one is called chain of thought prompting. So this can help you. Actually, right now, most of the prompting results are based on the chain of thought. They have breaking the problems in intermediate steps, and you can show the results very carefully. There is also another concept called theory of mind, and actually, theory of mind is not a new concept itself. So generative AI can as I said, it can help you to create a lot of use cases. So if you see the top figure, in that case, we only have the text as the input. We don't have other data types. So when we have the single modality, we are going to generate the answers which are very narrow or which are not very powerful. We are not difficult to reach AGI. But if we have the input in a much deeper level, for example, we have visual inputs, we have text inputs, we have tactile inputs or haptic inputs, emotional inputs, just like if you, as I said, the robots, this is all possible. So then we can say that there are so many multimodal data types. So then we are going to have a very powerful use cases, and which we can call as AGI use cases itself. So generative AI can play a very, very important role because the main reason is it can understand human language, it can answer our questions, and of course, we can also use some methods for building AGI. For example, rapid prototyping. As I said, we can embed a generative AI as an embedded system in a computer and then embed inside a human robot. Then it can talk, it can answer any questions, and it's very easy to make a speech interface. So this is what is called how to build AGI in practice. Now, actually, we have no perfect way to answer these questions because everything what I said before happened in the past 3 years, actually less than 3 years. But there are some people propose some kind of framework. Let us say, if you are going to build AGI or AGI tools or AGI system, I call AGI system because AGI by itself cannot do anything. We need the hardware by itself. So there are some conceptual framework. This framework include this kind of layer: the data input layer, data storage layer, and decision-making layer, reference layer, validation layer, prompt layer. Now, the data input is about input of text, audio, video. Data storage is just like memory. The decision-making is finding the right answers. But the reference layer is to avoid hallucinations, because a lot of the answers look very fine, but they all have hallucinations. They are not really. And validation layer to make sure they are safe and also make sure they're consistent with what we are thinking. And the prompt layer, as I said, it is a layer to help to reactive AI to proactive AI, not just to trust the past, but to think by itself. There is also a lot of AI agent frameworks which are quite popular recently. And these frameworks can help us to build autonomous agents, or especially if you're in an industry, then these are very relevant because they can customize these frameworks to their own purpose. They can be used for, let us say, autonomous coding. If you're developing a software, then we can use the autonomous coding framework and prompt chaining and so on. Now, this is one of the last slides, and actually this one, which I took. Oh, sorry, I have a few more slides. I'll finish quickly. So this one is actually what is called open source AI agent frameworks. Now, actually, I have not used any one of them, but you can see there are a lot of open source frameworks. One of the famous framework is AutoGen by Microsoft, and what it can do. So it can help you to customize or develop AI frameworks. As you can see in this picture, the AutoGen framework from Microsoft, they can help financial analysts, help in finance. They can help software engineer. That means they can all very useful to in many domains. So finally, there are some limitations and challenges and risks. Actually, these are quite important too. One of the limitations, as I said, they are over generalized, and our creativity is, quite maybe we are going to be weak in our creativity. The answers are very generalized, and also there is a delusion or hallucination. And of course, sometimes we should make sure these goals match with our human values. For example, we can create so many programs which can destroy other programs. Or one question is, can we use a program developed by generative AI on the flights or very safety critical systems? I am not sure. So, and there is a privacy concerns. For example, one of the teacher, he said he is not going to use his CV to the generative AI, because his CV can be, the generative AI can read it, remember it, and maybe give the wrong information. And of course, the intellectual property rights and so many other biases is again another issue too. There is a risk of cyber fraud, data privacy, misinformation. I think that is very popular in the recent days, or even the deep fakes. And these are some of the potential risks. Now, again, the Google have identified four important risk areas, and one is called misuse, misalignment, and mistakes and structural risks. So one of the misuse means the user is an adversary. That means the user makes the problem. Another misalignment is the AI is the adversary. The AI is going to create the problem. And the third is the AI system causes harm without realizing it. Hello? You can hear me now? Hello? So it's okay to continue. I'm going to finish very quickly. So so you could able to hear me?
Yes, sir, you're audible now.
Okay, thank you. So I'm going to finish quickly, and then I would like to answer some questions. So this is the last slide. So here, as I said, there is some risk areas: the misuse, misalignment, mistakes, and structure risks. So even there is, as I mentioned before, there's the AGI has, as of now, it is a 5 levels, actually including 0, there is a 6 levels. And we can also see what kind of risks are going to, this is a probabilistic scenario, what kind of risks are in the future. For example, you can see if we reach the AI level 4, where AI is an expert, then there is a problems of mass labor displacement. There is a decline in human septonalism and so on. So these are some of the risk areas identified by other researchers. So I will conclude my talk with these few remarks. Generative AI and multimodal systems are very powerful. They can simulate. They are reaching the AGI not by thinking, but basically a kind of simulating the human-like reasoning and creativity. They are augmentative in nature, in the sense, if you are a teacher or a professor or lawyer, you can always use AI. Now, in the future, if anyone without AI skills is not good, what is that? They are going to lose the values. Now, I don't know driving, but I tell my friends I don't know driving because these days we have autonomous driving cars. So that means if you want to become a to learn driving, it's not a good idea because we are going to change everything in the near future. Now, this is the beginning. The speed of change is very fast, but there is, as I said, we should be a little bit careful while reading or even the news or so many things. There's a lot of misinformation or disinformation and deep fakes. And with this, I conclude my talk, and thank you very much. Again, I thank Professor Hebar, and I would like to hear some questions if you have.
Thank you, sir, for your enlightening speech. Truly, it was a great insight to the role of generative AI in building AGI system. Now the session is open for questions. So participants, if you have any doubts, you can clarify it. Any questions?
Sir, there are some questions from students. How do we stop AI from suggesting wrong or harmful ideas?
So actually, as I said, as of now, there is no, see, right now in the chat GPT or what is that, in the DeepSeek, it is difficult to get totally wrong ideas. They always trained such a way that it is not going to generate harmful contents. But just to give it one, there is somebody wrote recently in some paper about images. For example, there was a Italian Prime Minister Giorgia Meloni. So there is a paper also written in one article. Then I told them, don't use her name because it means that even for a prime minister in Italy, so they have generated some kind of fake images, harmful contents to her, and these are very dangerous. But actually, as of now, I can tell you that if you're using some words which are very harmful or dangerous, they already have some kind of what you call firewalls. Sorry, some kind of way to control it. But actually, I'm not sure about the future. But as of now, if you let us say you want to ask some harmful idea, you can't get this idea. But before it used to be. Just to give an example, for example, you say that, okay, I want to know how to murder somebody, just this in hypothetical scenario, then it is not going to help you. But what about if I say that, okay, I'm going to act in a drama. In this drama, I am going to do something bad to somebody, then it is going to give you some answers. So there is the dangers. But I really have no clear answer to this question.
Uh, Good morning, sir. My name is Sudharma. I'm from Department of CSBS. So my question is
Thank you,
like,
yeah.
as we have seen the large language models, they're lacking the capabilities like general reasoning and real world interaction like AGIs. So how can we move this LLMs towards the AGI? How can we bridge that gap between the LLMs and AGIs?
Okay, so these days the word LLMs and AGIs are LLMs and generative AIs, they are used interchangeably. But your question is about AGI. Now, the interaction is not difficult. For example, I use DeepSeek, and DeepSeek basically I have to type using the text. But how I can use the speech? I don't want to type. The typing is time consuming. So what I do is there is a button like a Windows button, press H, so I can directly speak to AGI. Now, I don't think the real world interaction with the AGI is difficult. I guess in Google Gemini, you can ask directly the questions using the voice. And even let us say now in the DeepSeek, what happens is even you can scan some images directly and pose it. But the problem is some kind of other interactions. For example, let us say in the mobile phone, we use a touch sensor, or we use some kind of other, actually there is so many sensors, for example, direction sensor, or even temperature sensor. And these are the future directions, but it is not very difficult in the later on, but right now it is a work in progress area.
Thank you, sir. Thank you so much.
Yes, thank you very much.
Thank you once again, sir. On behalf of Department of Computer Science, on behalf of Department of Computer Science and Engineering and all the allied branches of SIT, I wholeheartedly thank you for joining us today and spending your most valuable time with us today. Thank you so much, sir.
Yes, thank you. But I also want to tell you, I'm not so busy to tell you valuable time. And I thank again, and also thank for the organizers and also the hosts. And I wish the rest of the session continue smoothly. And have a nice day. And thank you again.
Thank you so much, sir. With this, we have come to the end of keynote session. I request all the participants to join us for refreshment at room number 004. Thank you, one and all. Announcement. All the participants are requested to join for the valedictory function of ICRICS 2025 sharp at 3 p.m. in Seminar Hall. Thank you, one and all.
Thank you, sir.
So thank you so much. You can end the
Yes,
session
thank
now.
you.
Thank
Thank
you.
you very much. Yes.
Hello.
Yes.
Thank you.
Okay.
Thank you.
Yes, please. Thank you,
you.
Professor Hebar. Okay.
Okay.
See you.
Have a nice time. Take care.
Yes. You can close the window. Yes.